There are 5 key pieces of equipment you should be familiar with in the electronics lab. The power supply, the digital storage oscilloscope, the function generator, the desktop multimeter and the handheld multimeter. Additionally to these, there's the network or spectrum analyzer. The power supply provides power for the circuit you will build. To turn it on, press this button here. You will then have to set it up according to use. For digital electronics, use the keypad to set it to +5 volts and connect your red wire to the positive output. Then connect the green wire to the green output for the ground. This voltage can also be used for the 555 timer. For analog electronics, we need to set up the power supply to 15 volts on channel 1 and channel 2. Connect the red wire to the red output for +15 volts and the black wire to the black output for -15 volts. Connect the green wire to the green output for ground. You can also change the voltage using this knob and change the channel you're editing by pressing these buttons here. The signal generator is used to create different signals. You can choose here from a sine wave, a square wave, a pulse, or others. Once you choose the shape, you can change the frequency, the period, the start phase, and add an offset by pressing the corresponding button and typing in the desired value. Once you input all the values, you'll be able to send your wave through. Connect one of these cables to one of the channels. Remember, you'll have to press this button to make sure it goes through. You can use the oscilloscope to see the wave you've generated. Press this button to turn it on. Connect the other end of the cable to either of the channels. To see the wave properly, we need to change the scale of the graph. We can use this knob here to change the time scale on the horizontal axis, and this one to change the voltage scale on the vertical axis. Now we can see the wave clearly. You can use the cursor to get exact measurements on the wave at certain points. You can show 2 waves simultaneously, one on channel 1 and the other on channel 2, using the corresponding coloured buttons. You can change the position and the scale and enter a menu that allows you to choose AC or DC coupling. The multi-purpose knob will allow you to select your options. If you want to show only one function, click the menu button of the second function and it will disappear. Another important setting is triggering. It allows repetitive waveforms to be displayed on the screen in a steady way. The trigger synchronises the voltage and the time data of the waveform, enabling the waveform to be seen in a meaningful manner. Also, if the signal is noisy, you can stop the image to be able to observe it closely. The handheld multimeter measures current and voltage. To measure current, make sure you rotate the dial to one of the ampere options. Then connect the red wire to input A and the black wire to the COM input. Connect these in series to your circuit. If you want to measure voltage, rotate the dial to one of the volt options. Then connect the red wire to V and the black wire to COM. Connect these in parallel to your circuit. The desktop multimeter is also able to measure voltage and current. Make sure you press either the ACV for alternating current or DCV for direct current. Regardless of the current you're working with, connect the red wire to the red input on the right and the black wire to the black input of the right. This should be connected in parallel. For the current, you will need to press Shift, then press ACV for alternating current or DCV for direct current. Connect your wire to the black input on the right. For currents up to 3 amps, connect the wire to the white input on the left. For currents up to 10 amps, connect the wire to the white input on the right. This should now be connected in series. The current measured will show on the display. The spectrum analyzer can be used to measure the magnitudes of a signal for a set of frequencies within a given spectrum. When testing the frequency of the bar, we can plug in the analyzer at each end and determine the resonant frequency of the bar.